Hello there guys, today we are going to be looking at how to tackle these questions here. So this question, in order to solve them, we need to understand Kirchhoff's first and second law. Now Kirchhoff's first law, if we just do a quick recap, so Kirchhoff or Kirchhoff, depending on how you want to pronounce it, the first law of Kirchhoff is straightforward. It just tells us about the current will split whenever it meets a junction, okay? So if we have a junction, let's say we have current coming in, we have a junction, that means that this current will split, okay, and so on. So for example, let's say if I have I1, then I1 is going to split into I2 and I3, okay? Or if, let me just change the annotation. So if I have, let's say I2 here, and I2 is splitting into I1 and I3, okay? So pretty much, in order for us to understand, we just need to look at the flow of current. Right, let's tackle this first question here. So these are two parallel circuits. We are going to be looking at the one on the left in this case. Now there are two loops. We need to start with one loop. It doesn't matter which one you want to start with, okay? Either this one here on the left hand side or this one here on the right hand side. Now a circle like this, if you can't visualize it in your head, it's always great to break it down. So I'm going to break it down into two small circuits. So I got this one here. Okay, I'm just going to do a rough sketch. Doesn't need to be perfect. I have my cell here, cell here. Here we go. Right, let me just label the cell 10 and then 10 as well. I've got 200 ohms, 10 ohms. Let me just put the direction of the current this way, and this one's going up and this one's going here. Now there are two cells. We need to start, you can start with either one of them. Now Kirchoff's second law. So second law tells us that the sum of the EMF in the circuit should be equal to the sum of the voltage or potential difference across the component. Now let's take a look at the first one. Let me see. There's two. I'll start with this one here. Okay. Now current goes from positive to negative. So current will go from positive from here, go all the way around the circuit, and again come back here. And this is what we have. Alright, now let's take a look at the EMF. So the first EMF is 10. Okay, now we go around, go around, go around, go around. As you can see, when we go through this loop here, so if I use my mouse, if we go through this branch here, we are going against the current. As you can see, current is going up and we are going downwards, so we are going against it. So it's going to be negative 10 here. Now also it's going to be negative 10. Let me just write it properly. So 10 from the first one plus, because of the sum, negative 10. Now the reason why it's negative 10 is because if you look carefully, we are going against this positive here. So the way the cell is oriented, we are going against it, so negative 10. Now since there's only two EMF in the circuit, we only have two EMF there, equal to the sum of the potential difference. We have two resistors, so the first resistor is going to be, let's say, of the voltage across the first resistor, and then it can be the second resistor here. Now 10 take away 10, that's 0, equal to, now the voltage across the first one is going to be IR, the second one is also going to be IR. However, now let's take a look what current goes through the 200 ohms. So that's I3, so therefore that's going to be I3. And what current goes through the second resistors? Now the second resistors, we are going against the current, so we are going against it, so there'd be a negative sign, and that's negative I2. Now we plug the numbers, so 200 I3 take away 10 I2. Now we go and simplify this around. Okay, so I have 10 I2, therefore I have 100, sorry, not 100. So in this case, we just divide it. 20. Here we go. So this here is our first expression. Done. Now we need to move onto the second loop. Let me just go up. Now the second loop, we need to move on to the second loop. We are going to do the same thing. Quick sketch down. This one here. This one again. I'm just doing a quick sketch, not perfect. Let me just label this 20 volts, 10 volts. Now current's going this way, current's going this way, and this is 5 ohms, this is 10 ohms. Now, since the first loop we are going clockwise, okay, then the second loop should also be going clockwise in a sense. So we also should be going clockwise like this here, okay. Now the reason why we do that is because we don't want any confliction in the signs. Okay, so if the first flow is clockwise, then we all need to apply the same flow for the second one as well. Now we apply the rules of Kirchhoff's second law again. EMF is equal to sum. Okay, let's take a look at the EMF. So in this case, I'll start with the 20. So it's going to be 20. Now I'll go up plus 10. Now if you look carefully, positive, negative, positive, negative. So I'm going with the flow in this case. And then I go for the first one. So that's IR plus IR. Now the IR here is going to be I2R and then going to be I1R in this case. 30. Let's simplify this again further. So that's 10 I2 plus 5 I1, and then we have a second expression. Now, if you look at the first expression, there's I2 and I3. There's no, so I1 is not there. So what we need is to turn the second expression in terms of I2 and I3. Now, that's when we are going to apply Kirchoff's first law. Now we can see that I3 is going this way and I2 is going this way. So I3 and I2, they join together at the junction, and this gives us I1. So I can see that I3 plus I2 is I1. So now I'm going to substitute this in. So I have 30 equal to 10 I2 plus 5. I'll open bracket I3 plus I2. Now I keep going further. 10 I2. Let's simplify this even further. So that's 5 I3. Okay, pretty much we're just going to basic maths there, expand the bracket and so on. So I2 and I2, that's 15 I2 plus 5 I3. Okay, almost done. So now we have our final second expression. So we got the first one and we got the second one. Let me just leave it there. Now the good thing is we know that I2 is equal to 20 I3 from the first one. So we take this and we plug this into our nice equation. So this will become 30 equal to 15 20 I3 close bracket 5 I3. Okay, and we'll do this, and this will give us 300. So 300 I3 plus 5, 305 I3 divided by this much I3, and I3 will get our final answer if I just use a calculator here very quickly. So it's going to be 30 divided by this, so I get a very small number. Okay, it makes sense for I3 to be very small because the resistance here is very high. Okay, that's one thing, that's one way we can check it makes sense. So if the resistance is very high, the current going through it will be very, very small. Now we got I3. Okay, we are going to use the first expression again, so 20 I3 is equal to I2, so 20 multiplied by 0.98 equal to I2. So all you need to do is multiply this by 2 and you'll get 0.19 here. 7, so normally that's going to be 8 amps. I2 Okay, and now we know that, so therefore we know that I3 plus I2 is equal to I1. So you add them together, and you get I1 to be plus 0.295, and that's how you solve this question like this. Okay, I hope that this helped. Just make sure that you do practice those type of questions in this case. So whenever you have two loops, you're going to have, in this case, two expressions, and always remember Kirchoff's first law when the current is split in this case.